What if I told you the most powerful fuel in the universe is not inside stars, not inside reactors, not even inside black holes, but inside empty space? Right now, the space between you and this screen looks calm, silent, and dead. But, according to quantum physics, that nothing is actually boiling with energy. Enough energy to move stars, enough energy to cross galaxies, enough energy to completely rewrite humanity's future. Forget warp drives, forget massive fuel tanks. Today, we're going somewhere far stranger. This is the story of zero-point energy, the quantum vacuum, and why the emptiest places in the universe may be the key to limitless interstellar travel. Let's start with an uncomfortable truth. Space is brutally unfair. The faster you want to go, the more fuel you need. The more fuel you carry, the heavier you become. The heavier you become, the more fuel you need. This is the rocket equation. It's why chemical rockets struggle to leave Earth. It's why, even with nuclear fusion, we still find ourselves trapped in our local neighborhood. At our current pace, reaching nearby stars would take, decades or even centuries. And, well, reaching other galaxies would take longer than human civilization has even existed. The universe isn't just big, it's honestly, insultingly big. Unless, we're actually thinking about energy completely wrong. Here's where things get weird. In classical physics, empty space is just nothing. But in quantum physics, empty space is, well, kind of a lie. Even at absolute zero, when all heat should vanish, space still vibrates. Particles appear and disappear. Fields fluctuate. Energy, it seems, never fully shuts off. This leftover energy is called zero-point energy. Think of the universe like an ocean. From the surface, it looks calm. But underneath there's constant motion, waves you can't see, currents that never stop. And this isn't philosophy, it's measurable. The Casimir Effect proves it. Put two metal plates extremely close together in a vacuum and they attract each other. Not because of magnets, not because of gravity, but because the quantum vacuum itself pushes them together. Empty space is doing work. That alone should bother you. Now here's the part that bends your brain. When physicists calculate how much zero-point energy exists in space, the number is absurd, so absurd that it overshoots all known energy in the universe by a catastrophic amount. Most physicists assume something cancels it out, because otherwise, the universe would tear itself apart. But, here's the uncomfortable question. What if that energy is real, and we just don't know how to touch it? What if space itself is the fuel tank? Traditional engines push against something. They burn fuel and throw mass backward. Zero-point propulsion would work differently. You wouldn't carry fuel, you wouldn't eject exhaust. You'd interact with space-time itself. Think less like a rocket, and, yeah, more like a sailboat. A sailboat doesn't carry wind. It interacts with the environment already there. A quantum engine, in theory, would do the same thing with the vacuum. By manipulating quantum fields, vacuum pressure, or space-time geometry, a craft could generate continuous thrust without running out of fuel. No refueling, no mass penalty, no hard limit except physics itself. If sustained acceleration becomes possible, even at a modest level, relativistic speeds stop being science fiction. Weeks to nearby stars, months across stellar clusters, a human lifetime to other galaxies. Not instantly, not magically, but plausibly, if the physics cooperates. Now, let's be brutally honest. Zero-point energy is real. Zero-point propulsion is not proven. This is where most videos lie to you. Extracting usable energy from the quantum vacuum may be extraordinarily difficult or even impossible with our current understanding. Theoretical ideas include Casimir cavity manipulation, vacuum energy gradients, exotic spacetime metrics, and negative energy density engineering. Every one of these pushes physics to the edge. So, this is not a garage project, and it's definitely not a startup pitch. Honestly, it would require breakthroughs in quantum field control, materials that survive extreme forces, energy regulation beyond fusion, and computation at quantum scales. This isn't tomorrow's technology. But then again, neither was nuclear energy in 1900. If even a fraction of this becomes possible, civilization changes overnight, energy scarcity disappears, interstellar travel stops being generational, planetary isolation ends, colonies wouldn't be desperate survival outposts, they'd be extensions of civilization. Science accelerates. Resources multiply. Humanity stops thinking like a species trapped on a rock. For the first time, Earth becomes a starting point, not a prison. That's why this idea matters, even if it never works. Because it forces us to ask better questions. And now, the uncomfortable part. What happens when a species gains near limitless energy? History isn't kind to that question. Who controls it? Who decides where we expand? What happens if we encounter life that never asked for visitors? Zero-point propulsion wouldn't just be a technological breakthrough, it would be a moral one. We would need laws that scale to stars, ethics that extend beyond planets, restraint at a cosmic level. The universe is quiet. We don't know why. That silence might be a warning. What happens when a species gains near limitless energy? History isn't kind to that question. Who controls it? Who decides where we expand? What happens if we encounter life that never asked for visitors? Zero-point propulsion wouldn't just be a technological breakthrough. It would be a moral one. We would need laws that scale to stars, ethics that extend beyond planets, restraint at a cosmic level. The universe is quiet. We don't know why. That silence might be a warning. Zero-point energy may never power a spacecraft, but the idea itself already did something powerful. It reminded us that the universe is stranger than our assumptions, that nothing is rarely nothing. That limits often exist only because we haven't challenged them properly. Humanity didn't leave caves because it was easy. We didn't cross oceans because it was safe, and we won't reach the stars by playing small. If the vacuum itself is alive with energy, then space was never empty. It was waiting.